Before I start working out problem number 27, if you've been having any difficulty at all with related rates problems, I would say don't even bother watching this video. Don't bother trying to figure out how to do this problem. Wait until you know how to do related rates problems like the back of your hand and you are just looking to challenge yourself. This is a really challenging problem, and probably not one that you would see on you probably wouldn't see one like this on a test, just because it just takes too long. But with that being said, for those of you that want a challenge, here you go. I set it up, and you should after reading through the problem, you should be able to figure out that this is indeed a related rates problem. And a couple things that stand out to me here. You've got angle of inclination. Well, that's like an angle of elevation. So I drew a picture of the graph of y equals x cubed. You can see the blue curve here. You can see the no step would be the 3 centimeters per second. You've got the x coordinate increasing, so the dx dt is positive 3. And then, not that you would need this same scale on the x and y axes, I guess you would, but anyway, how fast is the angle of inclination of the line connecting the particle to the origin changing? So angle of inclination, we're going to call that theta, and then so d theta dt is what we're looking for at the moment that x is equal to 2. Okay, so we can safely put this angle of inclination theta in the first quadrant like you can see here, and then I'm just going to let x be the, if we draw this right triangle here, I'm going to let x be the value of the base of the triangle, and then x cubed then, or y, would be the height of the triangle, but since y is equal to x cubed, we're going to, instead of putting a y there, we'll put an x cubed. So we're labeling the triangle. Alright. So that's the setup, part of the setup, and then the relate step, though, is the tangent of theta. So you need to find an equation that relates theta to the x's, and so your tangent of theta is opposite over adjacent, you know, soka toa. Okay, so that's what we do. And if you look over here into the relate step, you see tangent of theta is x cubed over x, which is just x squared. Okay, and then I took the liberty of differentiating both sides with respect to t. I got crammed in over here, but secant squared is the derivative of tangent, so secant squared of theta d theta dt equals the derivative of x squared, which is 2x dx dt. So it actually starts unfolding and not being too bad once you get to this step, but I know that getting to this step is a bit difficult. So again, we're just going to solve for d theta dt, and let's do that over here in green. So d theta dt is equal to, if we divide both sides by the secant squared, is 2x times dx dt over secant squared of theta. And I'm going to write that as secant of theta squared. Okay, so we're really almost there. We want d theta dt at the precise moment when x is 2. So we're going to replace x with 2. So here's our x. We're going to replace that with 2. We're going to replace our dx dt with 3. And then the next issue is, what in the world is secant of theta going to be? Well, when x has a value of 2, this is the little extra work part that we see on many of these. Extra work. Okay. We have a right triangle, and I don't know, let's make it green. Now, we've got this theta in the lower left-hand angle of this triangle, and then we know that we want the d theta dt at the precise moment when x has a value of 2, which would make that the length of that side 2, and then the other leg of the right triangle 2 cubed, or 8, which, if we think about it, and we've got a right triangle, let's use Pythagorean theorem, and we can get 2 squared and 8 squared is 68. So the length of the hypotenuse of this right triangle is radical 68. And what do we know to be true about the secant. Well, cosine, we know, is equal to the adjacent over the hypotenuse. And so that means that the secant is equal to the hypotenuse over the adjacent. So the hypotenuse is radical 68, the adjacent is 2, and so we can replace the secant with radical 68 over 2, and then when we square it, we get 68 over 4, and 68 over 4 would be 17. Okay, so we have 17 down here, and so the dust is going to settle here. Let's do this part in blue. So d theta dt is equal to 2 times 2 times 3, which is 12, over 17. And we hope that that's an answer. Yep, there you go right there. D, 12 over 17.